In this session we shall see the design of highway with uniform cross-section. The design is based on the alignment of the center line of the road passing through the center of the median or central verge of the dual carriageway road cross-section. The main screen is opened. Select Working Folder Work located on the desktop. Next select File menu option New and then New Open Uniform Section Hill Road Design Project. As the workspace opens, the current selected tab is Create Project, the project name is Hill Road Design, survey data type is Total Station. We click on button Open Tutorial Example Data. As the selection box comes, we select the third option for design with bearing line data and next the data is loaded. In this workspace we can open a previous design only if it was done earlier with this workspace. Any other project data file cannot be opened to process in this workspace. The message box comes informing about next opening of MS Excel file for bearing line data, and as the Excel worksheet opens, select Menu File, then Save As and select Save As Type Text tab delimited star.txt in the folder Tutorial 5.3 Hill Road with bearing line data, created inside the working folder and click on OK. The file is saved with same file name as the Excel file with extension as say, bldata_file.txt. Next, we select the tab Process Survey Data. The current page is for Step 1 Ground Model. We click on button Create Ground Model. UTM data conversion is not selected here. The dialog box comes for bearing line data extract. Click on button Browse and select the bearing line text data file last saved in the folder Tutorial 5.3 Hill Road with bearing line data, created inside the working folder. The data is loaded in the dialog box. Next, click on button Extract Data and the message comes informing about survey data is written in file survey.txt and the list of intersection points of the alignment of the control line is written in file alignment.txt. Next we close the dialog box. Next, the list of all the survey features are displayed. We select the desired color and click on button Apply to All to draw the ground model for all features with the selected color. Next, we select Page for Step 2 Triangulation, select all the survey features and process triangulation. As the process is over, we select Page for Step 3 Contour. We create the contour model and save the contour model in the model files. Next we draw the contour model and the contours are displayed. Next, we select Tab Hill Road and the current page is for Step 4 for the design of horizontal alignment of the center line of the road. We select the option Halon Coordinate Inputs Traverse IPS. First, the list of coordinates as traverse intersection points are processed to create the Halon data, Next, the Halon data will be processed to design the horizontal alignment of the proposed road center line. The coordinate data is displayed and we click on Proceed. The design is done and the design report is written in file halonment.rep. Next we click on button View Halon Design for string M001 and display Schenage and details on the alignment string. Next we select step 5 to choose single carriageway cross-section type TCS07 from the available typical cross-section types to apply uniformly from start Schenage to end Schenage, and we click the button Save SIDOL data. In the trial or evaluation version, user is not required to save the SIDOL data. Next we select step 6 for design of vertical profile of the road center line. We click on button Create Ground Long Section, and as it is created we draw the ground long section. Next, we select the option Process via Line Design Data. The data is displayed and we click on button Proceed. The design is done and the design report is written in file via alignment.rep. Next, we draw the vertical profile. We display the grid and vertical details along the design string M001. Next we select step 7 to define cross-section, interface, and create cross-section. The current page is to define cross-section dimensions for median or central verge, main carriageways, earthen shoulders, or sidewalks, left and right service roads as applicable by following the typical cross-section type SIDOL for various Schenage sections as done in the last step. We can change values for various items as desired. We click on button Save Data. Next, we select the page interface to create data for stepped embankment slopes on left and right hand sides in cut and fill situations. The interface strings will be created as string I002 along the outer edges of the carriageways. Next, we select the page to create cross-section. We click on button Process Cross-Section Data. The process box comes with list of batch processes in proper sequence. We click on button Proceed to process each step with the related data as displayed in the lower part of the process box. Every time we click on button Yes, to draw the strings after all the processes are over, and finally we click the button Finish, and next all the strings which are just created are drawn as shown in the display. The entire design is now displayed on the plan window of the screen. We click on button Create Cross-Section Drawings. As the process is over, we select a desired Shehnage from the list of Shehnage sections to view the plan and the related cross-section. Next we select Step 8 to define pavement layers separately for the left and right carriageways of the main road. The data is displayed for pavement layers in main carriageways on the left and right throughout the alignment of the road. If we want to modify the data, the same may be done in the display of the data, or alternatively by clicking the button Define Pavement Layers and modify the data for each Shehnage section by selecting from the schedule, Loading Default Data, saving the data for each schedule. Next we click on button Process Data to create the pavement layers in the road cross sections. Next, we select Step 9 for estimation of quantities for earthwork and pavement layers. The default data is displayed on the screen. We can make modifications in various values, if desired. We click on button Process Data. Next, Step 10 to create project drawings for construction. The first page is for alignment schematics. We skip process data and to create the drawings for horizontal and vertical alignments in 2 successive processes. Next, we select the page plan to create plan drawing for various strings listed in the box. Next, we select the page profile to create profile drawing for various strings listed in the box. The start and end Shehnages are already displayed by taking from the previous design steps. The default length of road per sheet is always for the full length of the road alignment. This may be changed to 1000, in case the length of 1 km per sheet is desired. The horizontal scale is to be given suitably to fit the drawing to the length of the drawing sheet. The vertical scale should be 1/10 of the horizontal scale. We click on button Process Data to create the drawings. Next, select the page cross-section to create cross-section drawings at a given interval for the given length of the road. The start Shehnage, end Shehnage, scale, sheet size, and other data are given in the page. We can modify the data if desired. We click on button Process Data and a set of cross-section drawings are created. Finally, we select Step 11 to view various data files, design report files and design drawings now available with us. Click on button Create Update Project Data File. We can view the project data file, survey data file and various design report files by using respective buttons. We can view the design drawings in the CAD viewer by selecting from the list in the CAD viewer and save the drawings by selecting a desired format. This is the end of the current session for the design of Hill Road by using bearing line data, and we close the workspace by saving the project data file. Thank you.